Hello. So here we are considering another system of linear equation and we will try to solve it. So at first we will write down the augmented matrix. So here we are writing down the augmented matrix. So at first the coefficient matrix is 0, 1, minus 1, 1, 0, 2, 1, 1, 1. This is the coefficient matrix. And from the right hand side of this equation we are taking 1, minus 1, 0 and put a straight line in between those two. So this is our augmented matrix. So here you can see the first element, basically the element in the first row and first column, that is 0. So that cannot be our pivot element. So what we will do, we will interchange these two rows to make the first row begin with 1. So what we are doing here, we are interchanging row 1 and row 2. So we will get 1, 0, 2, minus 1, 0, 1, minus 1, 1, and third row will remain same. So this is our new matrix which we get by row operation by interchanging the first and the second row. Now we have to make all the element in the first column to be 0 except this pivot element. The second, in the second row we already have 0, so we have to make this one to be 0 which is in the third row. So what we have to do, we have to do R3 minus R1. So the first two row will remain same and the third row will become 0, 1, minus 1 and 1. Now in the second row, this is our pivot element which is already 1. So we have to make this element in the third row to be 0. So what we have to do, we have to make R3 minus R2. So let us see what will happen. 1, 0, 2, minus 1 will be the first row, it will remain same. The second row will also remain same. And the third row will become 0, 0, 0. So the third row is basically a 0 row with all the entries to be 0. So here this is our reduced row echelon form. So from this one we can write Rx to be B prime, where R is 1, 0, 2, 0, 1, minus 1, 0, 0, 0. This is R. This is our x1, x2, x3, and our B prime will be minus 1, 1, 0. So from the first row we will get x1 plus 2x3 equal to minus 1, and from the second row we will get x2 minus x3 equal to 1, and the third row will give us 0 equal to 0. So there is no absurdity as it was in the previous example where we can see that the equation, the system of linear equation had no solution, but here 0 equal to 0, so here is no absurdity. This is actually true. So we have two equations now. So from the first equation we can write x1 in terms of x3, which is minus 2x3 minus 1, and from the second one we can write x2 in terms of x3, which is x2 equal to x3 plus 1, and the last one is 0 equal to 0, which is absolutely possible, I mean which is exactly true, so nothing to do about that. So our solution x will be minus 2x3 plus 1, x3 plus 1, sorry, minus 2x3 minus 1, x3 plus 1 and x3. Now x3 can take infinitely many values, as there are infinitely many real numbers. So this system of equation has infinitely many solutions. Whatever value of x3 you put here, you will get the value of x1 and x2 according to these equations. So this system of linear equation which we have started with has infinitely many solutions. So let us see the geometric representation of this system of linear equations. So let us consider the first equation, which was x2 minus x3 equal to 1. So the plane will look like this in our xyz plane. The second equation was x1 plus 2 x3 minus 1, sorry, x1 plus 2 x3 equal to minus 1, that will look like this plane. And the third equation was x1 plus x2 plus x3 equal to 0. So this will look like this. Okay. So if we consider the first and second equation together, we will see that they will intersect at a straight line, which is like this. Okay. Now if we take equation 2 and equation 3, again they are intersecting at a straight line, and we can see that this straight line is like this. So if we consider the three equations together, we can see that the three equations actually passing through the same straight line. So there are infinitely many points on the straight line, and these three planes are passing through all those points. Basically they are intersecting in this straight line, so there are infinitely many solutions. Thank you.